Hello. So we are going to do a little review session on fractions here, and I have about 30 problems, and that might be too long for one video, but we'll see how much we can do, and then if need be we'll just do a second video so that you can space it maybe a little, but you can also stop the video, take a break and come back if you need to, right? Alright, so we're going to take it slow. We're going to start very basic, and then we're going to build on it to include the algebra. But so very basic first. When I need to add two fractions, I need a common denominator. So let's start why that is. So if I have a pizza and I cut it in maybe 1, 2, 3, 4 in fifths, right? So this is one pizza and it's cut in 5 pieces, right? So we cut it in 5 pieces. And let's say I'm going to eat 2 of those pieces, right? So I'm going to eat 2 pieces. So I ate 2 out of 5 pieces, right? It's a little shiny here. I hope you can kind of see that. So that's what that fraction means. So now let's say I'm going to have another pizza, but this one I want to cut in 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So this pizza is cut in 8. And let's say my hubby is going to eat 3 of those. Let's imagine he eats 3 of those pieces, right? So 3 pieces from the pizza that had been cut in 8 pieces, and I ate 2 pieces out of the pizza that was cut in 5. I can already tell you that I ate more than a hubby, right? But let's say we want to know how much we ate together. Well, if I add that, which is what we tried to do, right? How much did we eat together? Well, we really can't add 2 pieces here and 3 pieces here and say we ate 5 pieces, right? 2 plus 3 is 5. But 5 pieces out of how many? How was the whole pizza cut? One was cut in 5 pieces, one was cut in 8. Those are not representing the same sizes, right? This is why when you add or subtract fractions, you need a common denominator first, so that each pizza or whatever it is that you're comparing is going to have the same unit or single pieces size, right? So I would have to say, okay, I can't compare that, I can't add those two, so I'm going to multiply here by 8. What you do at the top, you need to do at the bottom, you need to do at the top. Why is that? Well, because now 8 over 8 is what I really multiply by, right? And 8 over 8 is nothing more than 1. So what I really just did here is have 2 fifths multiplied by 1. Well, 2 fifths multiplied by 1 is still 2 fifths. So this is why I'm allowed to do that mathematically, because even though it looks like I'm multiplying by 8 and by 8, it's technically just a multiplication by 1. 8 over 8 is 1. And so that's why we can do that, and that's why it's legal to do this mathematically. So that one, however, we need, so here we would have a 40 as a denominator, right? And so to make this become a 40, I need to multiply by 5 and by 5. So now what do we have? Well, 2 times 8 is 16, 3 times 5 is 15, and now this one is over 40, but this one is also over 40. So really, if I wanted to, I could rewrite that as 16 plus 15 all over 40, because now I know that I could take each pizza and cut it in 40 pieces, and then I would be able to compare how much pizza my husband and I ate together. So what would that be? 16 plus 15. You're not going to see that, I'm running out of the screen there. So that would be 31, 40. So if we cut those pizzas smaller, I mean in smaller pieces is what I mean, so that each pizza has 40 pieces, right? 40 of them. Then we would both have eaten 31 of those 40th pieces, okay? So that's why when we add, subtract fractions, we need a common denominator. So now let's do it. We start doing the drawing of the pizzas and the portions and the pieces. So I know I need a common denominator. I have a 15 here and a 5 here. Well, there is nothing I can do to 15 to make it become a 5 by multiplication, right? Because I need to multiply, not divide. So I'm going to have to multiply 5 by what to get 15? By 3, by 3. Here, this again is a multiplication by 3 over 3. So this is what I call this well-chosen 1, right? Because it's just a 1, 3 over 3. Multiplication by 1 is not changing anything, right? And so, but now I have a 15 in the denominator. This is what I had here. So now I can actually do that, right? So it will be 11 plus 3 times 3, which is 9. And now we have a common denominator, so I can write it like that out of both because it's common, right? They both have that 15 now at the bottom. Then you add your numerator. So 11 plus 9 will be 20. 20 over 15. But now notice how once we're done, we have maybe one pizza. Let's keep going with the pizza example. We have one pizza that we cut in 15 pieces, and we have 20 pieces. Well, then we obviously have more than one pizza, right? So we're going to have to simplify that. What can we simplify that? I'm going to do that actually differently then, but we have a factor of 5. I'm going to divide that by 5, divide that by 5, because they both can be divisible by 5. 20 divided by 5 is 4, and then 15 divided by 5 is 3. Okay, so my fraction is simplified. My top number is still larger, so technically this is absolutely fine. We can leave this way. But if I want to keep going with my pizza example, I would say, okay, well, I ate 4 pieces out of a pizza that was cut in 3. So I obviously had more than one pizza, right? So I ate 1 pizza, and then we have 1/3 left over after that. But this answer really is what we're looking for here. Alright, so now let's look at number 2. Number 2 is a subtraction, so every time you add or subtract, you're going to need a common denominator. So we need that same number at the bottom. 9 times anything cannot give me 5. 5 times anything cannot give me 9. So we're just going to multiply them by each other. So this fraction is going to be multiplied by 5, top and bottom. And this one is going to be multiplied by 9, top and bottom. Alright, so once I've done that, 5 times 7 is 35. And don't forget that x that's there, right? We're including a little bit of algebra here. And then 2 times 9 is 18. That was a minus between them. 2 times 9 is 18, and don't forget your x. And then all over, your common denominator now would be 5 times 9, which is 45. Now, the numerator are like terms also, right? And 35x minus 18x will give you a 17x. And that will be over your common denominator of 45. This does not simplify. How do I know it doesn't simplify? 17 and 45 do not have any common factor. There is no number that I can divide them both by. Okay? Alright. If you need me to go slower, just stop the video and restart, right? You can do that. You don't need me to repeat on the video. Number 3. Here we have 3 fractions. The 2 first ones we want to add, and then here we want to subtract. It doesn't matter that we have 3 of them. We add and subtract. We still need a common denominator. So let's analyze. So instead of just blindly saying we're going to multiply to get a huge number, we're just going to say, okay, what is 9? Well, I'm going to do this here. So 9 will be the same thing as 3 times 3, right? Then what is 12? Well, 12 will be the same thing as 4 times 3, or 2 times 2 times 3, right? Then 4, well, 4, I'm going to leave 4 as being 4 because I already have a 4 here. So that's just going to be, we're going to leave it as a 4. 4 times 1, or 4. Okay, so I have a 4 here, and I have a 4 here, but I do not have a 4 here. So I need to multiply that by 4. I have a 3 here. I have a 3 here, but I do not have a 3 here, so I need to multiply here by 3. Okay, so then I still have a 3 here, a second 3, which I don't have here or here, right? Here I have 1 but not 2, here I had 1 that I added. So we're going to multiply by another 3. 3 times 3 is 9. 9 no, I don't want to multiply by another 3. Let's analyze. So what did I just say? I said we're going to multiply this one by 4, so do that on the top. That will give me a 36. What can I multiply 12 then to get 36? Well, another 3, the second 3 I was missing here, right? So I have 1 3. That 4 is now common to both, so I need another 3 that I don't have. So that's what I will do here, multiply by 3, and then that now will give me my 36. See how those two match? And now I need to make that 4 also becoming a 36, so that will be a multiplication by 9, and that now would also be 36. So my common denominator will be 36. Alright, now let's look at the numerators. We multiplied by 4 here, so 2 times 4 is 8. And then we add a plus, addition. 5 times 3 is 15, and then don't forget your x, so 15x. And then 3 times 9 is 27, and don't forget your x. But that was a subtraction, so we need to put a minus there. Okay, well, we're almost done. The numerator has two like terms, right? We have a 15x and a negative 27x here. So we're going to simplify that. And 15 minus 27 is negative 12. So I have 8 minus 12x all over 36. And now we look, you have to keep analyzing. Every time you've done one step, you have to check and ask yourself, can I go further? Do I have any like terms I can put together? If you do, put those together like we just did here. Once you're here, the next question is, can I divide those three values by the same number? And you have to be able to do it to all three of them, or you wouldn't be able to do it to any of them, right? It has to be a common factor for all three. And if you're looking, 8 can be divided by 4, 12 can be divided by 4, and 36 can be divided by 4. So we're going to divide all of those by 4. So 8 over 4 will be 2. 12 divided by 4 is 3, and then 36 divided by 4 is 9, and so our answer here would actually be 2 minus 3x, don't forget your x there, over 9, and now that is your final simplified answer. Okay, again, if you need to re-listen to all of that, just go ahead and rewind and listen to it again. We're going to switch to division now. So when we add and subtract, we needed a common denominator because those pizza, if you remember the pizza example, have to be cut in the same size pieces, right? Each piece has to have the same size, so we can actually add them together and compare. Now we're multiplying and dividing, so that's completely different. We do not need a common denominator. But a division, we're going to have to change it to a multiplication. So this is over 1, right? When you just have a number, it's just like over 1. And then when you have a division of two fractions, you keep the first one, so 1 over 9. You're going to change that division to a multiplication. So change the division to multiplication. And this fraction is going to be flipped over. Is not a very proper mathematical term. It will be, we're using the multiplicative inverse, right? But that's what we're doing. So 6 over 1 becomes 1 over 6. And the reason we do that is because we changed our operation from division to multiplication. Those are inverse operation of each other, and so we're going to use the multiplicative inverse fraction, right? Okay, so when we multiply, we're going to multiply straight across, numerator with numerator, 1 times 1 is 1, and then we multiply straight across, denominator with denominator, 9 times 6 is 54, this will be your answer. Alright, we're almost 15 minutes here into it, So I'm going to try at least to do this one page for that first video. So now I'm looking at 5 multiplication, so it's not a division anymore, it's a multiplication, so we don't need to be changing to multiplication and use, since we use the inverse operation, we have to use the inverse fraction here. There is none of that here because it's already a multiplication. So just multiply your numerators together, multiply your denominators together, see if anything simplifies. I like to simplify before I multiply because it keeps my number smaller, but it doesn't matter when you do it, right? You could go ahead and multiply those two together, write your answer here, multiply those two together, put your answer here, and then see what simplifies. I like to do it before though. So 8 divides by 2, which becomes a 4. And so because I divide that by 2, one of those 2 has to be divided by 2 also, right? And 10 does. 10 divided by 2 becomes a 5. Now notice how I have a common denominator. That doesn't matter, right? This answer right there is not going to be just over 5 because I need to multiply, so I need to multiply those two together. So that will be a 25. And then 3x times 4x, so that will be 12. And x times x, don't forget, is an x squared, okay? Alright, and then we're thinking, is there any number I can divide 12 and 25 by? And the answer better be not, right? Because I didn't see anything else here, so there we go. Alright, number 6, it is already a multiplication, so I do not have to use multiplicative inverse, right? Because I'm not inversing that operation. I'm going to keep the multiplication, but I want to simplify. When you're multiplying 3 over 3, that will be like 3 over 3. Well, that's just equal to a 1, right? So because 3 over 3 is 1, that goes to 1. So we can cancel them out. X squared over x squared, well, this also is a number over itself that also is a 1. So the x squared and the x squared are also gone. You don't really see that well, do you? Maybe a little bit better. So what do we have left over? In the numerator, we have a 7 and a y. Let's already write that. We have to do one more simplification, but let's write that already. And then the 3 is gone, that's gone. We have a y squared left. Okay, we could have gone ahead and addressed that here, but I wanted to clean it a little bit so that you can really see. So now I have a y over a y squared. So y over y squared really is y over y squared, right? Y over y. So that means that one of those y cancels with one of those. And then I have a 1 left on the top over y. So the 1 on the top over y. So this y goes, cancels the square, and we're left with 1y at the bottom. So 7 over y. Okay? Number 7. 7 is an addition, so attention, right? We have to be careful with those signs because we're adding. I need a common denominator. I need my two pizzas to be cut in the same sizes for the pieces, for each piece, right? The same size, and they're not right now. So this is a 40, this is a 5. So I'm going to multiply 5 by 8 so that I can get a 40. So that's now a 40, right? And what we do in the denominator, we need to do up here so that when we multiply, we're not changing the original fraction because it's just 8 over 8, which is just a 1. Okay? I'm insisting on that because it's important. That's why we're allowed to do it, because it's just a well-chosen 1. All right, so let's do it. So negative, don't forget that negative right there. Negative 2 times 8 is 16a, so we have a negative 16a. Plus, and here I don't have to multiply by anything because it's already a 40, so it's already my common denominator. So plus a, and then my common denominator, as I just said, is 40. Those are both like terms, right? They both have an a, so I have negative 16a plus 1a will be equal to negative 15a over 40. And now we're almost done. And we have to simplify. There is one number we can divide both of those by, and that will be 5. So 15 divided by 5 is 3, and 40 divided by 5 is 8. So right there, this answer, don't forget your negative, will be negative 3a over 8. There we go. All right, number 8. Number 8 is a subtraction, but it's a subtraction of a negative. So when we subtract a negative, those actually become positive, right? So then I have over 3 and over 3. Notice how those two already have a common denominator. So that will be equal to negative x. We said that will become plus 11x over my common denominator, because it's an addition, subtraction, right? Not a multiplication. And then those are like terms, so we're going to put them together. Negative 1 plus 11 is 10, so 10x over 3. 10 and 3 do not have any factor in common, so we can say this is our answer. Alright, now this one is very similar to the one we saw on the summer packet quiz, right? The first one that gave you so much trouble. So this is just a division, just like we did up here, right? So when we divide, we use the inverse operation. So inverse of division is multiplication. And because I'm inversing the operation, I need to inverse the fraction that's coming after it. So we're going to use multiplicative inverse. So that's what we do here. We're going to do a 5 over 2 divided, you need to see that as a division, right? It's a division bar, by 3/5. So we have 5 over 2. We change the division to a multiplication, use the opposite, the inverse operation of division. But because we use the inverse, this fraction right here has to be inversed also. We need the 5 over 3. Multiplicative inverse of the denominator fraction. Okay, now it's multiplication, so we just multiply the numerators together and the denominators together, and this does not simplify any further. Alright, one more on that page, then we're going to stop this video and start another one. So we have 2x over 3 divided by 5x squared over 6. So we keep the first fraction, right? 2x over 3. We change the division to a multiplication, use the inverse operation, and because we use the inverse operation, we need to use the inverse of this fraction. So the multiplicative inverse will be 6 over 5x squared. Okay? Let's see if you can simplify anything. 6 divided by 3, and 3 divided by 3 becomes a 1. And then 2 and 5 do not have anything in common, so that's it, right? Now let's look at the variables. X over x squared, so this x goes and it cancels the square, and we have 1x left, right? So we have 2 times 2 is 4 over 1 times 5 is 5, and then 1x left over, so over 5x. Alright, let's stop this, and I'm going to start another video for the next page, okay? So, see you soon!